who were sketching in I1, we were mostly sketching graphs, and we didn't really know where the vertex was until afterwards. Today, the key thing that when we graph ours, we're still going to be looking at those x and y intercepts. We're going to be looking at maximums and minimums of our functions. We're going to be identifying those, but the key thing in our previous lesson, we worked with quadratic functions with no middle terms. So all of ours that you graphed yesterday had no x term. They had like an x squared, then plus a number, or they just had an x squared with a positive or negative, okay? We are now going to have equations that are going to get a little more complicated. This is standard form. So we're going to talk about 3 different forms. Today we talk about standard form. Coming up on Wednesday, we go to vertex form. And then we're going to look at factored form with this unit. So it says, in the equation above, how does the A affect our graph? How does our A affect from Friday when we were looking at this? What does the A do? If it's positive, it tells our parabola to do what? Open up, right? So if A is greater than 1, when we look at that, if A is greater than 1, that's still going to be the case. Our parabola is going to open up, right? And actually, it shouldn't be greater than 1. It should be greater than 0. All positive ones are going to open up. And if A happens to be negative, less than 0, then our parabola is going down. It's still going to be that parabola shape. So it says, what effect does A have on our graph? It tells it to go up or down, and it also changes that width. So that quiz that we were just looking at, if I have 1/4 x squared, that's going to be wider to if I have 2x squared, that's going to be narrower, right? So it changes the width. It also changes if it's going to go up or down. So we want to keep that up or down part with it also, okay? So in our equation above, how does the C affect the graph? Well, when we think about that C value, what we want to write down for that C value is that when we are looking at that, the C changes our y-intercept. Exactly like we did in our last lesson in I1. It changes that y-intercept. But the key thing here, where there was always the same y-intercept, if it's a non-zero b, it won't necessarily be the exact y-intercept. And that's what you're going to see today, is that when we add this term, the bx, this isn't always going to move it necessarily up 4. So you got to be kind of careful with that, okay? So on that next page down, you have these 3 equations. So it says, look at the 3 equations in the graphs. They all have an A value of 2, so they all have the same width. Okay, so they all have 2x squared as we look at those. The next thing as we are looking at each of those graphs, the C value is 0, so that it crosses the y-axis at 0. So if we are looking at those, all of them have a 0, but they have 2x, 4x, and 6x. So when we are looking at it, it says they all have a different B value. So what did we notice about the location of the axis of symmetry? Our axis of symmetry here was -1/2. In this one, it was -1. And here it's -3/2. So it says when we are taking a look at this, let's see if I need to move. All right, let's see. A divided by B, which is 1. We look at here, 4 divided by 2 gives us 2. 6 divided by 2 gives us 3. Well, where was our first axis of symmetry? It was at -1/2, right? So axis of symmetry, x is equal to -1/2. And the second one, it was x equals -1. And the last one, -3/2. So what they're looking for is for you to kind of come up with, what do you do to answer the question when you get b over a in order to get the number from the equation for the axis of symmetry? So what did we do to this number to get to -1/2, to get to 2, to get to -1, to get 3, to get to -3/2? And so what we are taking a look at is what you want to write down in that part. When there is a non-zero b value, meaning it's something other than 0, the axis of symmetry is always going to be located at. And how we are going to write that is we are going to have x is equal to -1/2 times b over a. And a lot of times we're going to put it in this simplest form. X equals -b/2a. That is my x coordinate of my vertex. So when I'm trying to write the vertex, how I always get that is to get this x coordinate that's here it is always going to be negative b over 2a when I look at my equation. So when I have you today, you are going to be calculating that. So make sure on that very bottom part, down at the bottom, that you have written this, okay? Then you're going to always solve for the y. So some of you haven't written that yet. As we take a look at this, when we graph the equation for the axis of symmetry, so the first thing I'm going to see on your paper is you are going to write down x equals negative b over 2a, just as I did here. If you need to identify in your equation, our a is equal to what? In front of x squared is negative 1. B is 4, and C is, you gotta be careful, negative 2. Now we don't need the C, we mostly need the A and B to find our vertex point. So when we are looking at that, we are going to say x is equal to, we're going to put negative b, which is negative 4. So it's negative, and then we're putting the b divided by 2 times a, which is negative 1. So negative 4 divided by negative 2, my x coordinate for my vertex is going to be located at negative 4 divided by negative 2 gives me x equals 2. I need to find the vertex, though. So the vertex is an ordered pair. It's always my x comma y. We have just found the x coordinate. To find the y coordinate, you're going to go back to the equation. And now you're going to place in the x value. So we're going to go with negative, and then we are going to put 2 squared. This is different than the negative being inside the parentheses. Why is it outside? Because it's negative, and then it's the x squared plus 4 times x, which is 2 minus 2. So if you need your calculator, you can, but we're looking at negative 4, right, plus 8 minus 2 should give us an ordered pair. Y should be equal in this case to 2 also. So we get the point 2, 2. That's our vertex. So we're going to go to the point 2, 2. Is my parabola, by looking at the a value, going up or going down? Down, because a was equal to a negative 1, so I know my parabola is going down, right? I know it's going to have a maximum point because the a was negative. So at this point, I know it's going down. It's going to be symmetric around this point. So my axis of symmetry is when x equals what? Where's my x coordinate? 2. So draw an axis of symmetry. It has to be symmetric around that line. Next thing it says, pick 2 or 3 points that will be used on the graph. Use the line of symmetry to your advantage when picking points, meaning you do not want to pick negative 2, negative 1, 0, 1, and 2, right? You want to pick points around the axis of symmetry, around the x, that vertex. So when you put your x, y points, I'm always going to put my vertex in the middle. Why do I want the vertex in the middle? It's going to always be symmetric for a quadratic. So if I pick 1 and 0 for my other x, 1 and 0, on this side I would want to pick 3 and 4. And I'm not even going to solve for all of them. I'm only going to solve for 2 of them because it should be symmetric. Now I could always check it to do the other ones, but when I take a look at this one and I plug in 0 into my original equation, so going back to that original equation, we were looking at y equaled, and our equation was negative x squared plus 4x minus 2. So if I plug in 0 in that equation, what do I get? Negative 2. I don't even have to show the work for that, right? We love plugging in 0 because I plug in 0 to all this. The only thing I'm left with is the c value, negative 2. So at 0, I know we're at negative 2. What does that mean over at 4? If I plug in 4, it should be. It should be negative 2. And if you're not sure, you can always do that check. You can plug it in and go negative 4 squared plus 4 times 4 minus 2. Negative 16 plus 16, yeah, that equals negative 2 also. So I only really have to solve for the 1. So I'm going to plug in 1. It's negative 1 squared plus 4 times 1 minus 2. Keeping in mind you're not squaring -1, so you're squaring the 1, so that's -1 plus 4, which is 3. 3 minus 2 leaves us with 1. And again, I am not going to solve this one because I know it's symmetric, right? And it should come up. Now the weird thing is for some of you when you get that fractional part, that is we take a look at this, and it's going to have my graph. That's what I'm looking for when you plot this, okay? We're going to go to the first part. In lesson
9.1, use h equals -16t squared plus c to find the height of h above the ground of an object falling from an initial height c at the time t. If an object projected into the air given an initial upward velocity v continues with no additional force acting on it, the formula h equals -16t squared plus dt plus c is the approximate height above the ground.
now keep going.
Entertainment. During a halftime of a basketball game, a slingshot launches t-shirts at the crowd. A t-shirt is launched with an initial upward velocity of 72 feet per second. The t-shirt is caught 35 feet above the court. How long will it take the t-shirt to reach its maximum height? What is its maximum height? What is the range of the function that models the height of the t-shirt over time?
So when we look at this problem, they're launching it, right? And it's going up in the air. Any of you ever been where they're launching t-shirts? It doesn't usually go in a pretty straight trajectory. It usually kind of goes up and comes down. That's the shape of our parabola. Where is it starting? They're starting it at 5 feet. It's going up. We know the velocity is 72 feet, and it's going to be caught at 35. And the question they ask is, what's the maximum height? If you're going to find the maximum height, that's the what of our vertex? The maximum height. That's one of our vertex points, right? That's either the x or the y. And then it says, what is the range? So on the top of the next page is where we start looking at this question a little more in depth, okay? So notice that they replaced the v with 72. Why 72? Because they told us in the problem that our velocity was 72. -16, that's gravity. That's the force of gravity on our equation, okay? Why 5? We started at 5 feet, okay? So it says h is going to be our height of feet, in feet. T is going to be the seconds. The coefficient of t squared, it's always negative because our parabola is always going down, right? So if you think of them launching it, this is like those people where they're standing, they launch it, it goes up, and then they catch it, okay? Well, we got to have this down further because this is at 5 feet, and this was at 35 feet that they caught it at. And so we're trying to find this like point right up here. We're trying to find how high that is. And notice it's T and H. So when we look at our ordered pair, it is always going to be, when we are taking a look at it, the time, that's our T in our equation, and H is our height. So we're going to be able to easily find the maximum height because that's our y coordinate, right? So this is the x and y of our vertex. Only thing we call it T and H in this problem. So how long will it take to reach the maximum height? That's the first question. What is the maximum height? So how long? That's asking us to find time. Time was velocity in 72 feet per second, so time is going to be seconds to find that. So how do we start off? How did we find the x coordinate of our vertex? We are finding it with T equals, everybody, the equation is negative b over 2a. So when we find our x coordinate, okay, x was negative b over 2a of our vertex, okay? So I need everyone to say that a few times. So t equals negative b divided by 2a. That was kind of wimpy. So we look at our equation, and as you look at your equation, what is our b value up here? So negative b. So b is 72, right? A is negative 16. So we are going to take negative 72 divided by 2 times negative 16. So negative 72 divided by, if we are looking at this,
30.
divide, please.
32. Oh.
Take your calculator out, divide.
Is that really?
Okay? 2.25 seconds. This is this t coordinate or x coordinate of our vertex. It took that t-shirt 2.25 seconds. That's my x or my t, the time. I now need to find out. So I could already answer this question. How long did it take? 2.25 seconds. What is the maximum height? So now I have to find the h. All that means is I'm going to go back to this original equation and write it, but replace the h or the t with 2.25. So I put down negative 16, and I put 2.25. I'm squaring that. You definitely want a calculator. Plus 72 times 2.25 plus 5. You're going to put that whole thing in your calculator. Do that now. Get 86. Make sure you put it in your calculator. So this is 86, and that's 86 feet. So this is it reached in 2.25 seconds, it reached 86 feet in the air, and then it came down. So make sure that if you can't get that, putting it in your calculator, it's negative 16 times 2.25 squared plus 72 times 2.25 plus the 5. That gives us our 86, and in this case, that's our feet. So the maximum height, 86 feet. The next question says, well, what is the range of our function? That means, what are my, if I'm looking at it, what are my, as I look at that problem, what's the minimum that we can look at for our time that we are talking about? And what's, when we talk about, that's our domain. But our range, what's the lowest height?
5.
No, the lowest that the t-shirt starts at, the lowest height is at 5 feet. Because that's where they are launching it from, right? So 5 feet. And the highest it goes, they catch it at 35, but the highest that our t-shirt goes is 86. So 2.25, it hit 86, it came down to 35. Jack.
Are you only square?
Maximum height 86, 2.25, and our range is between 5 and 86 feet. So, as you look at this next one down that you're going to practice. So, we are going to be asked to write an equation. So keep in mind, the equation is always of the form negative 16 t squared plus the velocity times time, and then plus your starting point. When we think of that starting point, that is our c value. So it says from a height of 5 feet, so we already know in our equation that c is plus 5. It says that they are using a slingshot and the velocity is at 64 feet per second. So we also know that this is 64 t. The first part stays the same. H equals negative 16 t squared. Okay? So how long does it take the t-shirt to reach maximum height? We're looking for the time. So that is of our vertex. That's the t and the h. The equation is t equals negative b divided by 2a. Later this unit, we all get to sing the quadratic formula song. I know, it's so exciting. You'll hear me sing it first, of course. So, as we are taking a look at this, t is equal to, what is our b value as I take a look, Wyatt? What would be our t value, or our b? Ax squared plus bx plus c. What's my b? Okay, so negative, and b is, so I'm going to have negative 64 divided by, I'm going to have 2, my a value that I'm looking at, Joel, is 2 times negative 16. So you're going to take on your calculator a negative 64 and divide it by negative 32. This one is so nice, isn't it?
I think I just did.
It is.
This is beautiful.
2 seconds. This is nice. Okay? So, should get 2 seconds. We now need to find the height to the original equation. Caleb, tell me, quiet please. 16.
2.
Caleb, what are we replacing t with?
2.
2
Squared
squared,
plus 64 times 2.
Yep.
Plus
put all of that in your calculator to tell me our maximum height. So this is what's happening. They threw this t-shirt launcher at 5 feet. It is going up. They are catching it at 35 feet. And we are trying to find how much time the T and the H. We know it was 2 seconds. And we should have had how many feet?
69.
I did that.
So, if I am asking you the last part, what is the range? So the range is talking about not our time. Time goes from 0 up to this time, and we're not looking at that time. We are trying to look at what is our height. So the height, if we are looking at the range for our height, the lowest is 5. The highest is 69. They caught it at 35. Okay? So when you are looking at those problems, so when you do your homework on page 556, it says this. I'm going to hand you out graph paper. It says, on the paper, quiet, please, write the equation. So you will write out the equation. The next thing that I will see on your paper, yeah, you can hand that out. So the next thing I will see on your paper